This video lecture, we are going to learn about the transportation problem. The transportation problem is a special type of linear programming problem where the objective consists in minimizing transportation cost of a given commodity from a number of sources or origins to a number of destinations. Here in this figure, you can see that these are the factories and these are the warehouse. So commodities have to be transported from the factories to this warehouse, and each transportation cost is given. For example, San Francisco to the San Diego, it costs about 5 units. So the data for the modeling of the transportations includes the level of supply at each source and the amount of demand at each destination. So for example, San Francisco can supply about 1,700 units, and then San Diego can take about 1,700 units only. Similarly, Los Angeles can 2,000 units, while Manchester can take only 1,000 units, etc. So units of transportation cost of the commodity from each source to the each destination. Here the 5 per unit, 3 per unit, 4 per unit, etc. So there is only one commodity, and a destination can receive its demand from more than one source. The objective is to determine how much to be shipped from one place to the another. A necessary and sufficient condition for a feasible solution is that total supply should be equal to total demand. If it is not, then we have to balance it. So what do you mean by a balanced transportation? If the total supply is equal to the total demand, that is also known as a balanced transportation. Otherwise, it may be known as an unbalanced one. The allocation cell in the transportation having positive allocation are called occupied cells, and the empty cells are known as the non-occupied cells. This is the formulation of a transportation problem. So where S1, S2, etc., Sm are the source, and D1, D2, etc., Dn are destinations, and Cij, C11, C12 are the cost from S1 to D1, S1 to D2, etc. So in generally speaking, Cij means that from the source I to the Dj, the cost of the transportation per unit. So if you want to get a basic feasible solution, then there must be about number of row plus number of column minus 1 allocations. When the number of positive allocation is lesser than row plus column minus 1, then we call it as a degenerate solution, otherwise it is known as non-degenerate solution. An ordered set of at least 4 cells in transportation is said to be loop provided any 2 adjacent cells of the ordered set lie either in the same row or the same column. An even number of at least 4 cells must participate in the closed loop. All cells that receive plus or minus sign except the stating unoccupied cell must be occupied cell. Each row and column in the loop should have only 1 plus and 1 minus sign. Closed loop may or may not be square or rectangular shape. Prohibited routes are denoted by the infinity or very large m value. Now see this, the mathematical formulation of transportation problem. So here Xij is the total units transportation from the ith source to jth destination. So mathematical model is written as the summation of Cij into Xij. So here where Cij into Xij total cost transported from the ith source to the jth column. Now we have to minimize the total cost. So that is summation and summation of Cij into Xij, subject to the supply constraint. That is here see that the supply constraints are, that is S1 can supply maximum to the S1, S2 can supply maximum to the S2. That is known as the supply constraint. The supply constraint is that summation Xij should not exceed Sj, and demand constraint is that the sum of Xij should not exceed this Dij, or in other words they should be same. So let us formulate the formula following the transportation problem. S1 to D1 take cost 19 per units S1 to D2 about 30 per units, etc. And D1 have a maximum demand of 5, D2 has the maximum demand of 8, D3 has the maximum demand of 7, D4 has maximum demand of 14, and total sum is 34. While S1 has maximum capacity of 7, S2 has maximum capacity of 9, and S3 has maximum capacity of 18. The total is 34 again. So hence this is a balanced problem. So the objective is to minimize that 19x11, 30x2, 50x13, 10x14, 7x21, 30x22 plus 40x23 plus 60x24 plus 40x31, 8x32, 70x33 plus 20x34, subject to the capacity constraint, that is x11 plus x12 plus x13 plus x14 equal to 7, and this like 9, and this one sums to the 80, and the requirement constraints is x11 plus x21 plus x31 is equal to 5, similarly to the other requirement constraints, while xij is greater than or equal to 0. Now here what is the main problem is that there are about 3 into 4 12 decision variables, and we have about 7 constraints. So since this number is very high and we cannot use the simplex method here, so there must be another methods to solve a transportation problem. So this is the main drawback of the simplex method, that when a number of variables is too high and if the constraints are too high, then it is very difficult to solve. So that's why we are going to learn more about other methods to solve a transportation problem. In this transportation problem solving procedure, first of all, we have 3 methods to find a feasible solution. The first one is northwest corner rule, least cost method, and the Vogel's approximation method, or we call it another word is penalty method. So through these methods we will find the feasible solution, and then we will test using modified distribution method to check whether these feasible solutions are optimal or not. If it is not, then we will modify this matrix using this modified distribution method and repeat this process until we get an optimal solution. First one is the northwest corner rule. In this method, we will start with the upper left corner, and then we will allocate the minimum amount of available to the selected cell and adjust the associated supply and demand quantity by subtracting the allocated quantity. Then exit the row or column when the supply or demand reaches 0 and cross it out, and to show that you cannot make any more allocations to that row or column. If a row or column is simultaneously 0, the only cross out 1 and leave the 0 supply or demand in the row or column that is not crossed out. If the exactly one row or column is left that is not crossed out, then stop. Otherwise, advance to the cell to the right if a column has been crossed out, or to the cell below if a row is crossed out. Continue step 1. This trial routing method is often far from optimal. So in other words, we call it, this will give you a worst solution. Let us take an example over here. So S1 to D1 about 19 per units, S1 to D2 cost about 30 per units, and etc. So here again, this is a balanced problem. Select north or cornered part, that is 19, and from here in the 19 cells check the supply and the demand, and from this if you see that here the demand is 5 and the capacity is 7, the minimum is 5. So assign 5 over here and subtract 5 from 7. So that's why. So here it is 0 and here it is 2. Similarly, take another corner, that is 30. So now this is the remaining cells, and D1 does not need any kind of materials, so because it is satisfied right now. S1 need to send about 2 units, and now in 30 repeat the same procedure. Check which is minimum, 2 or 8. 2 is minimum, so that's why here it is 0, and 8 minus 2 6. So S1 does not left anything to supply, so that's why it is satisfied right now. That's why we have crossed that corresponding row. Similarly, in the remaining cell, the 30 is another column. So in the 30, the minimum is minimum from 6 and 9, it is 6. So we assign 6 units in that cell and subtract 6 from here and subtract 6 from 9. So we will get 3 over here. In the remaining cell, select the 40 as one. Northwest corner is the 40 and made from minimum of 3 and 7. Select 3 and subtract 3 and 7. So we will get 4 and at last we will get single row and assign 4 over here and again we assign 14 over here, and we see that this is the final assignment. So this is the final feasible solution. So here the total transportation cost is 19 into 5 plus 30 into 2, 30 into 6 plus 40 into 3 plus 70 into 4 plus 20 into 14. That will cost about 1015. So here there are about 1, 2, 3, 4, 5, 6 assignments. So that is 3 plus 4 minus 1, that is 6. So hence it is a non-degenerate solution. Least cost method is a method in which we will consider only those cells which having a least cost, and then we will allocate the transportation corresponding. So in this example, let us see that among all of the elements, 8 is the least cost. So from in that 8 we will consider the minimum of 8 and 18, and we assign 8 over here and subtract 8 from 18. So we will get 0 over the demand and the supply about 10. And then from the rest of the cells we will consider the minimum, and we see that 10 is the minimum one. So assign minimum of 7 and 14, which is 7 and 7 over here, and we will have a 7 over demand. So remove this row, and again if among the rest of the cells we will select the minimum, which is 20, and assign the minimum of supply and demand, that is 7 is the minimum. So I have assigned the 7 over here. Then again from the rest of the cells select the minimum. So 40 is the minimum. So if we see that there are two 40s, so in such cases take random any one of the cell and assign to it. So hence 40 is this 40 is chosen, and from the minimum of 9 and 7, 7 is chosen. Those 7 is assigned over here. Then and at last here from 70 and 40, 40 is the minimum. So assign 3 to that 40, and again at last we have a 7 over here and apply assign 2 to this cell. And in the end, just this is the final assignment table. So where we will have a 7 units from S1 to D4, 2 units from S2 to D1, 7 units from S2 to D3, 3 units from S3 to D1, 8 units from S3 to D2, 7 units from S3 to D4. The total transportation cost is about 840, and here number of allocated cells is equal to 6. Hence this is a non-degenerate